this demonstration, you'll learn how to generate a mesh for a flow volume when your model does not contain a body to represent it. In my workflow, I'll use a volume creation task to extract the flow volume, and then I'll use a meshing task to generate the flow volume mesh to model internal flow. I've already imported my geometry, which is a model of a coupler with 11 openings, 10 inlets, and 1 outlet. I'll start by adding a volume creation task. The next suggested step is to add a volume definition. There are two types of volumes I can define: extracted volume and geometry simplification. Extracted volume is used for extracting a flow volume for a fluid simulation, while geometry simplification is used for solids. In a conjugate heat transfer simulation where fluid and solid coexist, I would use geometry simplification to create the solid volume and extracted volume to create the fluid volume. My simulation is a fluid simulation, so I'll define an extracted volume. To model internal flow, I need to select the bodies that bound the flow region. In other words, the bodies in which or through which the fluid flows. By default, all 29 bodies are selected as the bodies bounding the flow region, so I don't have to take any action here. I do need to create a point inside the flow region, though. This point is important because it will represent the flow volume. One way I can create a point is to select a face and then click Create New. In response, AIM calculates the centroid of the selected face and places the point in the appropriate location inside the flow region. The next suggested step is to add construction geometry. I need to add capping surfaces to close all the openings to make sure the volume will be watertight. There are 11 openings to cap. Here's what it looks like after I select the 9 inlets on this end of the geometry. Now I'll click the plus sign. Then I'll add the side inlet and the outlet for a total of 11 faces. Now I'll return to the volume creation panel. Before I create the volume, I'll set some global sizing controls. To create a volume quickly without modifying the preset global sizing controls, I could use the predefined settings and adjust the mesh resolution slider. But for this case, I want to manually set some controls to optimize my mesh in terms of element count and refinement. First, I'll disable the predefined settings option. Because there are no proximity locations to be refined, I'll change size function method to curvature. Then I'll set minimum and maximum sizes. I'll keep the other defaults. Now I'll click here to create the volume and bring the volume creation panel up to date. My next step is to add a meshing task, which I'll use to generate the flow volume mesh. Before I generate the mesh, I want to add inflation, so that inflation layers will be generated on all the walls. I already defined a selection set called Walls, which includes all of the surfaces except the inlets and the outlet. Here I'll define an inflation control and choose Walls as its location. Now I'll return to the Mesh panel and click Generate Mesh. After the mesh has been generated, I can zoom in for a closer look at the inflation layers, as I've done here. To check the mesh quality, I'll add Mesh Diagnostics. Here I'll change Mesh Metric to Skewness and review the diagnostic data to check whether the quality is acceptable. This concludes this demonstration of the workflow for volume creation and volume meshing in AIM.